In match problem 1, even though all 4 parts here may not look necessarily related, in fact, all 4 parts of these are applying the exact same property. And in particular, the property we're going to apply here is that the derivative of any constant is always 0. So for instance, we want to find the derivative of our function f of x, which in this case is negative 24. So the derivative of negative 24 is negative 24 is a constant, so that derivative is just 0. In part B, we want to find y prime, where y equals 12. So the derivative of this equation y, this function y, is again just 0 because 12 is a constant. C and D tend to be the types of problems that trip people up a little bit because we look at some more complicated expressions here. Here we have the negative square root of 7. Just because we have a radical doesn't mean that this is not a constant. We could plug this into a calculator. The negative square root of 7 would be some repeating decimal number. Since there's no variable here, so if we had an x somewhere in there, we would have a variable to take the derivative with respect to. But in this case, the negative square root of 7 is just a constant. So again, here the derivative is just 0. We didn't start off with a whole number, just a nice fraction. We've got a square root in there, but still we're just taking the derivative of a constant. The other type of problem that will trip people up is when we're taking the derivative of something like negative pi. Or a similar problem would be taking the derivative of e. So something to keep in mind is that pi and e are both reserved in this class as being specific values. Pi is 3.14, etc., etc. E is 2.78. Again, some repeating decimal from there. So anytime we encounter a pi or an e, we're just taking the derivative of a constant. So the derivative of negative pi is, again, just 0.